Good afternoon, everyone. This is Kamesh Raghavendra from NetApp. I'm here to talk about a joint collaboration university internship we are doing. And as you can see on the slide, the goal is to create a graph, a social graph out of the OpenStack community network and allow users to query that graph. So what we're trying to create here is a property graph that includes three kinds of entities, community members, of course, developers, customers, service operators, interactions between these community members that includes emails, blueprints, code check-ins, bug interactions, and contexts gleaned out of these interactions. So this includes the location of the users, the parent organization where the members are working in, and the OpenStack project associated with those interactions. And we're building this property graph as an open SaaS web portal that consumers can query both in the form of canned queries that we plan to support as well as ad hoc queries. As I mentioned before, this is a joint initiative between NetApp and PES University, which is a very popular university in Bangalore in India, and Red Hat. And we are proud to be associated with Professor Dinkar Sitaram from PES University and Vijay Bellur from Red Hat in this project. You can find the URLs of the SaaS portal itself on this slide. We started this project only in March this year, and we hope to have a stable release by the Paris Summit timeframe that more people can widely use. So we had three distinct business motivations behind going down this path. The first was helping product strategy and product management for OpenStack related vendors and OpenStack related service providers. It was really challenging as a OpenStack supported vendor to clean out patterns of consumption and patterns of OpenStack deployment. We always had this question, who are the emerging demographic segments who are adopting OpenStack, what kind of customer support we should engage in rolling out OpenStack-based deployments. And we believe that this approach can help us query and discover those patterns of consumption that can enable vendors to define product strategy and product management. The second business motivation was marketing, understanding consumer segments, consumer demography, who are the key demographic segments who are deploying OpenStack, adopting OpenStack, and what are the touch points to engage with those key demographic segments. And the third motivation is understanding, how do we enable the OpenStack community? Who are the key influencers? As you can see, community members tend to be multifaceted. There are developers who are also consumers. There are service operators who are also contributing back to the community. So understanding this multifaceted OpenStack member behavior was the third business motivation in this attempt to create a graph-based abstraction of the entire OpenStack community network. So what did we do? So we went ahead and kind of merged and integrated all the open data sources that are out there in the internet around OpenStack. So we mined about 60,000 emails that were sent across multiple mailing lists. We mined about more than 10,000 support forum posts where different members of the community posted their experience using OpenStack and seeking out help from other members. We tracked the bug tools where people commit patches, people ask for patches, and that was around more than 6,500 of them. We mined blueprints where people ideate, people post what they want and what they are doing with OpenStack. And as we speak, we are trying to mine other sources of data in creating this property graph network that we are designing here. So this is kind of the property graph model that we have, and we are evolving this and improving it. As you can see, the people, the person entity in the middle of the graph is a key pivot, because it's finally people who are creating this community graph in the OpenStack community. And below the people, you can see the various forms of interactions that connect people with one another. It can be the bug posts, it can be emails exchanged between people, it can be blueprint-oriented ideation and conversations. And from these interactions, the tag entity below that is the context we are trying to glean from that. So for example, in an interaction, we can glean the OpenStack project the interaction is all about. We are also building libraries that can glean the sentiment, whether someone who is posting a support request is happy about something or unhappy about something. So those are the contexts we can glean from the interaction. From the people, the name, the domain, the email address, we can glean a lot of demographic context. It can be the parent organization where the person is working or is representing. It can be the location where the interaction happened or the person comes from. And from the parent organization, we can also glean the industry vertical that the member represents. And therefore, as you can see, there is a demographic context that comes from the nodes that represent people, and there is an interaction context that comes from the the edges, the interactions between the community members. And together, you can see this property graph emerging, which we have hosted on Neo4j, which happens to be one of the most popular open source graph databases, which also has a much easy to use Cypher query language. And this whole model is what we are building, and we are exposing it as a portal for people to use and query. So here is a very short demonstration of what the portal looks like, just to get you started. As you can see, we have tried to simplify the UI. It's just a simple query field and an execute button. It supports Cypher Neo4j query language. We hope to make it easier to use going ahead. And the entire graph schema is laid out below so that you can know the right terms to use in your query. As you can see, the query format has 3 clauses, which is the Cypher syntax. The match clause allows you to create the connections that you want to query. So it can be country linked to organization linked to person, kind of a graph path. The second clause, which is where, lets you add constraints on the path. For example, you want to query all the paths coming from a particular country, or a particular organization. And the third path, which is the return path, allows you to aggregate things like summation, count, so on and so forth, which is the actual metric that you're trying to glean out. We have some sample queries here. For example, this query tries to figure the most important books submitted from a particular country, and this is a query which is already stored there, so you're free to edit it or use it as it is. And once you hit execute, which this demonstration video will do soon, you can see the entire query executing and showing you the results on the side. There you go. And as you can see, we have hosted it on a web server, and it takes just a few seconds to query all those tens of thousands of nodes and edges that we saw before, and give you the most prioritized bugs that came from a particular geography. There's yet another query which talks about the popular industry verticals in UK who have adopted OpenStack and therefore are participating in all the data elements we have queried. And the third sample query here talks about the most important OpenStack projects in Germany, with a quantified list of all the interactions coming from people in Germany, interactions located in Germany, and tagged by OpenStack project, gleaned from the context of the interaction. So as you can see, this is a very powerful tool which can be used for doing multiple deep queries, and because of the graph model, it's very easy to express the logic you're querying, and the results come in a matter of few seconds. Here are some queries as sample examples. You can see the most popular OpenStack projects in Japan, for example. In the video we saw Germany, here it's Japan. Most popular industries in UK adopting OpenStack. So these are very complex questions which probably takes hours and days of analysis, which can run in a matter of seconds because of the graph model that we have built here. For example, this is a funny query where you can query who are the top 5 contributors of OpenStack who work in weekends. So you can filter on time and only filter out interactions in the weekends and sort it by descending order. And you can see here are the folks who are so engrossed in OpenStack that they don't mind spending hours together in their weekends contributing to the community. And you can see Canonical, HP, Yahoo, the usual suspects, but a big shout out to these guys who are contributing even on their personal time. What is the road ahead? So obviously this is still a young project. We are trying to improve the automation of extracting data. Right now it's a very manual process. We are trying to do it in an automated way daily so that we can give users back a more real-time snapshot of data. We are trying to extract more context. I talked about sentiment before, so there are open source libraries we are using to extract deeper context from the data. We are trying to enhance the user experience. We believe the user experience is already great because of Neo4j and its simplified query interface. But we are trying to add more natural language oriented user interactions for more people to use it easily. We are trying to bring more canned reports so that the most popular queries that are on top of many people's minds, we can query them for them and put out the results when they land in our portal. And finally, we're looking out for more data sources that can provide richer insights to our users. So we are here looking out for new collaborators. So if you're interested in this portal, or you would like to work with us more closely and building more features in it, feel free to reach out to us. My email is there on the title slide. So look forward to continuing down this road and hope to have a more advanced version of this portal by the Paris Summit in November. Thank you so much.